So this time we are having a lecture series of three lectures, which is on ancient Indian mathematics, and the subtopic is geometry in ancient India. And we are discussing the contributions of Bodhayana. So I welcome all of you, all the personalities, professors, and others who are working in different institutions or companies. So I welcome all of them for this lecture series. Good evening to all of you. So let me start my talk, and Professor Deshmukh will join soon. So here I want to say something about mathematics. Contribution of Bodhayana is a topic, but it is something from Mahaviracharya. So there is a Sanskrit word, Bahubhir Kipralapaihi Kim Trailokye Sacharachare Yat Kinchid Vastu Tat Sarvam Ganitena Vina Nahi. So some people they think mathematics where mathematics is useful or where it is used, but Mahaviracharya, he was a mathematician in the 9th century, and he has said that there is no point in just meaningless talking, because he says whatever is there in the world is not without mathematics. So mathematics is used everywhere. So this is something which we should keep in mind. And Mahaviracharya, a Jain mathematician of the 9th century, and he has given many examples of this thing. And then there is a need to know ancient Indian mathematics. So many things were done in ancient India, and the current mathematics is based on these developments of mathematics from ancient times. Especially in India, a lot of contributions were there by different mathematicians, and they used mathematics for different applications. So these applications were in using arithmetic, geometry, algebra, and astronomy. And then those achievements have profoundly shaped modern science and technology. The origin of calculus also is seen in the medieval India. So in the 14th century we had Madhavacharya, a mathematician from Kerala school, who has immensely contributed to calculus, especially the sine and cosine series were given by Madhavacharya, is now well known. So ancient mathematics actually is, of course, it has a collection of numerical techniques, and decimal system especially is the basis of all this. But it is a philosophical journey that interweaves spiritual and practical insights. And one should study ancient mathematics to appreciate India's rich mathematical heritage. So what we study in ancient mathematics is arithmetic, astronomy, geometry, algebra, and calculus. These are the basic things. And this arithmetic came from the times of Vedas, and Vedas are before 1500 BCE or much before that. Lagadha was a, can say, mathematician or astronomer in the 1200 BCE that time. Bodhayana 800 BCE. Aryabhatta. So the times of Vedas, Lagadha, Bodhayana, they are approximate. One doesn't know exactly the times. People have made various opinions about their period. But Aryabhatta was in the 5th century, and Bhaskaracharya 12th century, and Madhavacharya in the 14th century. That is well known. So the arithmetic starts from Vedas or before that, where we see decimal system. But geometry starts with Bodhayana in India, and astronomy starts with Lagadha. Algebra, it is there, but it starts with Aryabhatta, we can say, and many other mathematicians are there in between, and Bhaskaracharya collected all the work of previous mathematicians and contributed with his own research. And for example, Bhaskaracharya obtained the formula for volume of a sphere in India. Uh, so then we have Madhavacharya, who we can say contributed to calculus. So Indian decimal system and the names of place values from ancient times to modern times. So decimal system developed in India only, and it went to the other countries. And Rigveda, Yajurveda, these contain the names of place values. So Eka, Dasha, Shata, Sahasra, and so on. So 1, 10, 100, 1000. Now 10,000 there is name Ayuta, which is seen in Rigveda. For example, Ayuta is the name for 10,000. And then Aryabhata, Sridharacharya, Mahaviracharya, Bhaskaracharya, they gave various names to the powers of 10. So place values, they gave various names, which we are also using. And then all these names went to the other countries and they also started using similar names. Then Lagadha, Vedanga Jyotisha was his book in astronomy. Then Bodhayana we want to discuss today, and in the next two lectures. He is the first known geometer of India, and he was around 800 BCE. As you will see, he is much before the Greek mathematicians, which were geometers. And Surya Siddhanta is one text in astronomy. So these various Siddhantas about astronomy were collected by Varahamihira. He was in the 6th century. Then we have Pingala, combinatorics. So combinatorics, some of the basic principles were given by Pingalacharya in the 3rd century BCE. So these are the mathematicians, we can say, who were there before Christ. Lagadha, Bodhayana, then those who wrote Surya Siddhanta, names are not very clear, but Varahamihira collected the work, and Pingalacharya. So before the dates of all these, there is Indus Valley civilization. So the origins of Indian mathematics can be traced back to the early Indus Valley civilization, which was at the time of, so this 2500 is approximate date year before Christ, BCE, to 1900. So these were the dates of Indus Valley civilization. So this means about 5,000 years ago. And some archaeological findings reveal the use of standardized weights and measures. You will find pictures of excavations and where there are weights of equal volumes and size are seen. So equal volumes and size, that tells us these are some weights. And brickwork is also seen. So this brickwork uses geometry. So the early practices hint at a sophisticated understanding of arithmetic and geometry that laid the groundwork for subsequent development. So we find the first instances of applicable mathematics, especially geometry, in the excavations. And there are cities like Harappa and Mohenjo-daro. So they showcase sophisticated understanding of geometry and measurement. And it was like SimCity, computer game, which was played from those times. Actually, interesting thing is in ancient India, religious and philosophical thoughts were intertwined with mathematics and sciences. So many religious practices in India, they are based on science, which we should still appreciate. And many religious things were intertwined with mathematics also, as you will see. So Shulva Sutras are the ancient texts, and these were by various people. So Bodhayana is one of them, and there are others. So Bodhayana Shulva Sutras, Apastamba Shulva Sutras, Manava Shulva Sutras, Katyayana Shulva Sutras. So there are Shulva actually is for measurement, and Shulva means card. So you are measuring using a card. So just as we have a measuring tape nowadays, which is marked one, but in those times we did not have marked tape like that, but we can use card. So these cards were used for geometry and for constructions, various constructions, means constructions of building and so on. And in the religious aspect, we had construction of altars, Yajna Kunda. So these constructions used various geometrical theorems, and these theorems nowadays we study in schools, but these theorems actually came from the time of Bodhayana at least. Actually, these were known much before that, but what Bodhayana did was he collected all these important results in geometry which were required for him, so required by him for the construction of altars. So various Yajnakundas actually he demonstrated how to construct these Yajnakundas. So this is one example of a Yajnakunda which is seen as Purola Uttarkashi excavation. Altar of the shape of a bird such as hawk or eagle. So this is probably from the Kuninda king's period. These kings were during this period 150 BCE to 250 AD. So this was the period, and in those times there were some yajnas were done, and this is an excavation of a yajna kunda or altar. So these are various shapes, different shapes for altars in those times, and in different excavations many such altars were actually found. This is Mohenjo-daro and Harappa excavations. You will see bricks and their specific arrangements. So this construction of the city and buildings there, all these require geometry, and lot of geometry is seen from the work of Bodhayana. So you see here roads and so on, and many pictures are there where you see roads which are perpendicular to each other, just as they have a chessboard. So you see that geometry was developed to some extent in those times also, and they had grid-like structure akin to our present-day cities. The streets intersected at right angles, so that tells us that some knowledge of basic geometry was there in those times. So this is around 5,000 years ago. And in Vedic rituals also there was geometry required. Yes. So before construction of a building, you require a blueprint, how it will look. So similarly, the actual construction of altars that required some diagrams, and they were uh, created using geometrical principles. So various geometric patterns were used in rituals, and they were believed to resonate with certain energies and spiritual dimensions. So use of geometric shapes was there. What geometrical shapes? So usually basic shapes are a square, a circle, semicircle. So these were geometric shapes. But apart from that, there were shapes for altars of birds. For example, you can have a hawk, or you can have even tortoise. So tortoise shaped altar was there. So if I want to construct a tortoise shape, altar, then I cannot do it all of a sudden. I should know already how many bricks are required, how many layers are required to have an altar of the shape of a tortoise or of the shape of a hawk. Then what are the sizes? Are they rectangular or you want triangular bricks also to construct a tortoise or some other? There is a chakra type altar is there. So, do you, if you know beforehand the number of bricks required, then your job will be easy. So, Bodhayana has actually given the number of bricks required and their arrangement so that once you know all these things, you can directly go and construct this altar. So, you are already prepared for that. Just as the structure of a building is already done by the civil engineers and architects, and then accordingly the building is constructed. So there are different types of altars, squares, circles, rectangles also, and others. And the construction was a sacred mathematical process inviting divine presence. So they used to utter mantras from Rigveda and Yajurveda and so on. But these different types of altars were also there because we always think that God, when you pray God, then God gives us boon. So similarly, if you have some specific desire, then for that desire, a specific shape was used, or so like circular or square or tortoise shape, hawk shape. So these were used for different wishes that the yajamana or the performer of the yajna had in mind. Now the question is, who is the first known geometer in the world, in India and in the world? So Greek mathematicians are known for geometry. So each one of the Greek mathematicians is first known geometer. So can you think of who can be the first known geometer in India and in the world? And the answer is actually the mathematician about whom we are discussing today. So you see here, this is a list which is available also in the internet. You can see that. So Bodhayana, he was around 800 BCE, and Manav, he is also Indian, and he actually can be Manu also. So Euclidean geometry he also had, and he used it for this his Churva Sutras. And he was immediately after Bodhayana, as has been suggested. Then you see many Greek mathematicians. So Pythagoras, everybody knows Pythagoras, Zeno of Elea, Hippocrates, Plato, and others. Many other Greek mathematicians are there. There is a big kind of series of mathematicians from this Greek. So Apastambha is also, Apastambha is from India again, and you see Katyayana in the 3rd century BCE. They can be before also, but we don't know exactly. But some scientists, mathematicians, and others, they have decided their approximate timing, and these were decided by studying the language that they are using, the words that they are using, or the language that they are using. From that, they have decided the period. So you see that Bodhayana was around 800 BCE and Katyayana was in the 3rd century. So this is a period of 5 to 6 centuries, and during this period, what mathematics was developed? Of course, Greek mathematics was there. Greeks were, they studied a lot of geometry. You see Apollonius of Perga, for example, conic sections he studied. So he has various theorems in geometry, Apollonius theorem as we know. So Bodhayana now is the most ancient known geometer in the whole world because there is no documentation of any other person in Greece. Other Greek mathematicians were at a later stage. So we can be proud for this thing that the known mathematician is Bodhayana. It is like, Rigveda is the most ancient book all over the world. There is nothing, no book you can see which has survived. So from ancient times they used to learn by heart the mantras, and that kind of collection of mantras is there in Rigveda. And this is the most ancient knowledge that we have and the whole world has. So similarly, Bodhayana, the most ancient known geometer in the world, is also from India, and we should know that. And Pythagoras and others, they were after Bodhayana. So Bodhayana was born in Mithila area, and he did sadhana at Bandgaon. Bandgaon is near a sarovar. There is a sarovar, and this is in the Mithila area. And it is said that there is a pimple tree, and he used to do sadhana there. Now this Bandgaon is now known as Bodhayana Sara. Sara is for sarovar, Sara. So it is a sarovar, and there he used to stay in the Mithila area. So he was born around this time 800 BCE, and he is the most ancient geometer which is known. And now here you will see something interesting. Do you see a temple of any mathematician? So Bodhayana, Swami Bodhayana, his temple is there. The great Indian mathematician Bodhayana. It is available in the internet also. If you search for it, the idol of the Indian mathematician Bodhayana at Swami Bodhayana Mandir in Bongaon village of Sitamarhi district in the Mithila region of Bihar. So because he was from the Mithila region of Bihar, so his temple is in that area, and it is a unique thing that a mathematician's temple is there and he is worshipped there. So because of the knowledge which he has given in geometry especially, he is very much honored. And it is said that he actually wrote 200 books. That's what is said. We don't know whether he really wrote 200 books or not, but that's a feeling in that part. And once I saw also in a newspaper that there is a birthday of Bodhayana which is celebrated in that area, for which some minister came and so on. So these books which he wrote near this Bodhayana Sara, so these are related to science of religion. So science of religion, that is religion of course, but the science associated to religion. His childhood name was Upavarsha, and you might have heard of Panini, who was considered as the first known grammarian. Before Panini also there were grammarians, but Panini's work has survived and is studied now also. And this Panini was a disciple of Bodhayana, and he stated the currently known Pythagoras theorem. So we study this Pythagoras theorem as a theorem of Pythagoras, and but this Pythagoras theorem is already stated in the work of Bodhayana. This Pythagoras theorem used to be called as Koti, Bhuja, Karna, Nyaya. Nyaya means theorem. So it's a rule. Koti, Bhuja and Karna. So in a right angle triangle, we have Karna, that is hypotenuse, and Koti and Bhuja, one side is called Koti and another is Bhuja. So this theorem is also called Shulva theorem. Shulva theorem. So Shulva and Shulva, you can use both the words. B and V, both are okay. So you can say Shulba theorem or Shulva theorem. So why it is called Shulba theorem? So Shulba, it is because it is first available in the Shulva Sutras. And Bodhayana Shulva Sutra, which is most ancient. There are other Shulva Sutras, because all the Shulva Sutras, they were written for yajnas. And then they use geometry. And Shulva is actually uh, cord, or you can say string, small string, or you can take a rope, whatever you like. All these are Shulva. And because it is the first, and it is available in Shulva Sutra, so they will say Shulva theorem. It is there in the Shulva Sutras. So, Shulva Sutra of Bodhayana. So, first of all, there is this word Sutra. So, what is Sutra? Sutra is something written in chart. So, in those days, people did not have, ways of writing and keeping it. It was very, you can say, difficult. One used to write on what is called Bhurja Patra, or some other kind of. So, the skin of a tree that was used, or palm tree. You take a palm tree and its leaves. So, palm leaves are used to write. And then it is difficult to preserve. So, all that. So, what people used to do in those times was to remember everything by learning by heart. Important principles you learn by heart. That was the idea in those times. So, if there is a novel, it is not possible to just learn the whole novel by heart. So, the important principles, they were written in chart, but in short sentences, or some interesting poetry. So, later mathematicians used some poetry, like Bhaskaracharya has verses, and one can learn these verses, like nowadays we can remember stotras by learning by heart. Similarly, you can learn by heart these sutras. So that's why people used to write in chart, don't explain much. Then when they are actually giving discourses or lectures, then they will explain the things to the students. And the students will learn the sutras so that they don't have to remember much. If you remember a sutra related to the Pythagoras theorem, then you can develop that, give proofs, etc., construct the proof like that by discussing with others. So, this Shulva Sutra of Bodhayana, which was written around 800 BCE, it has 10 adhyayas. Adhyaya is a lesson. So, lesson number 1 or chapter number 1, we can say. So, chapter number 1 actually contains geometry here. So, in all there are 519 sutras. Sutra is a statement in prose form. It is not a verse. So, sutra, these so many sutras were written by Bodhayana. But not all of them were in for geometry. Okay? The sutras in the first chapter were containing principles of geometry. So there is a different period for Bodhayana given by different authors. Some people say he is between 1000 BCE to 800 BCE. Some give period 800 to 600, 800 to 500. You know, it is like the period of Bhaksali manuscript. People give different, even carbon dating is also not completely good for Bhaksali manuscript, as we know. So Bodhayana Shulva Sutra was a part of Prasna XXX of Bodhayana Shulva Stauta Sutra. Stauta is coming from Vedas, and you know that there is Rigveda and Yajurveda. So this is related to what is called Krishna Yajurveda. And Krishna Yajurveda is a part of Krishna Yajurveda. So Krishna and Shukla, there are, Krishna means in subject black and Shukla means white. So there is Krishna Yajurveda and white or Krishna, that is Shukla Yajurveda. So Krishna Yajurveda is older than Shukla Yajurveda. And it is said that Krishna Yajurveda is somewhat unorganized, and the later one, that is Shukla Yajurveda, is more organized as compared to the Krishna Yajurveda. So Bodhayana, he was related to the Krishna Yajurveda, that means he was much before the other people. That is understood. That is also that also shows his ancient period. So the aim of these Bodhayana Shilva Sutra. So Bodhayana is the name, and something done by Bodhayana is Bodhayana Shilva Sutra. Okay, of Bodhayana. Bodhayana means of Bodhayana. So the Shilva Sutras of Bodhayana, they are called Bodhayana Shilva Sutras or Bodhayana Shilva Sutras, we can say. So it is like Gauss theorem or Gauss's theorem. So Gauss theorem is Bodhayana Shilva Sutra. Gauss's theorem is Bodhayana Shilva Sutra. It is like that. So the aim is to. So what is this aim of writing that book? Bodhayana Shilva Sutra. What is the aim? Aim is to give construction of higher places for yajna, that is fire sacrifice, and the sutras deal with placing of fire in various things are there. How to place the fire in the fire pan, then preparation of the fire pan, preparation of the ground for the fire, piling of the layers of bricks, first to fifth layers. Sometimes for some altars, 5 layers were required. Then how many bricks are there required for the first layer? Then second layer, less number of bricks are required. Third, still less number of bricks are required. So like that, for all the 5 layers, or sometimes 3 layers are enough. So whatever it is, how many bricks are required, and moreover, what are the sizes of these bricks. So all that was discussed in detail by Bodhayana. So you see that this is a simple kind of altar. You had seen earlier the altar which was in the shape of a hawk. So here it is just a square kind of altar, but it has still, you see, 4 to 5 layers, and you should at least know, even if you know, say that it is a very simple kind of altar, you should still know at least approximately how many bricks are required if you want a specific size of the altar. So depending upon if the very large yajna is there, because many times whenever yajna is there for a single person, then it can be a small altar. But if it is there for the whole city, for example, or whole town, then it can be a larger yajna kunda. So depending upon the size, they have to decide how many bricks are there. Or sometimes what they do to make the thing simple, they say that if you want a larger yajna kunda, you have the same number of bricks, smaller yajna or larger one, same number of bricks. But what you can do is you can enlarge the size of enlarge the brick, okay, make it double size, triple size as per requirement. And then the question is, suppose you want a brick whose volume is double. This is a difficult question. How will you construct? What are the dimensions of that brick? Or there are questions like, in a specific room there are 25 students, and I want to have a room which is a square type room in which 50 students are to sit. Then what are the dimensions of that room? Such questions are there which are similar to the construction of bricks. So this construction, how to construct these fireplaces, this is found in also Shatapatha Brahmana, which was there around the same time. It was a commentary on the Shukla Yajurveda. So Brahmana means something. This Brahmana word is used for different things, but here the meaning is a commentary on a Yajurveda. That is called Brahman. So commentary can be on Rigveda. That is a Brahman for that. Then commentary on the Shukla Yajurveda. Now, Shukla Yajurveda, as I have told you, is in the later part. It is after the Krishna Yajurveda. So this commentary was written by Yajnavalkya Rishi. And this is also there. It is a treatise of Shukla Yajurveda school. So this also, that Shatapatha Brahmana is also It discusses geometry, which was required for this construction of altars. And Apastambha, Manu, they are Krishna Yajurveda people, and Katyayana is Shukla Yajurveda person. So he comes later as compared to the people who work for Krishna Yajurveda. So although people wrote the sutras, which are called as Shulva Sutras, Shulva is referring to measurement or cord. So complex higher altars, and this provides scientific knowledge of geometry. But not only this is there, they also in some sense require calculations of pi. So pi means, what is this pi? Pi was the word pi used in those times? No, it was not used, but this was popularized by Euler, as we know. But instead of pi, they used to say the ratio of circumference of a circle to the diameter. So we know that any two circles, for them, this ratio is the same. The ratio of circumference of a circle to the diameter of the circle. So that is pi. So in short, nowadays we say calculations of pi. But the question for them was, if you know the diameter, then what is the circumference of the circle? Can you say what is the circumference if we know the diameter? If you know radius, they usually don't say if you know radius, find diameter, find the circumference. They don't say that. Why? Because radius means you should know the center of the circle. But diameter, you can just measure like that by using some parallel lines in some form. Okay. And Siddhartha Brahmana also, because this is a known word, many times people talk about Siddhartha Brahman. So that's why I mentioned this, and it also has Pythagoras theorem. But before this, it was already known to Bodhayana. And there are some discussions of planetary distances, and Earth is circular. These such things are there in the Vedic period. That is, Earth is round. And what are the contents of Bodhayana Shulva Sutra? So there are 10 chapters. Now, first chapter gives the main principles of geometry, which are used in later chapters for construction of different types of altars. So there are in all 519 Shulva Sutras, and out of them, the first chapter itself contains 117. So many sutras are there about geometry. So it must be having many things. Whatever results are there in geometry which we study in the high school, they are there. Apart from that, the geometrical theorems like Pythagoras theorem, they are required for construction of altars, and they are already there. So Bodhayana was the first to describe in detail the geometrical propositions and measures of bricks of different types to suit in different types of altars. He also gave something interesting, rational approximate value of square root of 2. As we know, 2 is an irrational number, it is not rational. Root 2 is irrational number, it is not rational. So, in that case, you should find an approximate value of root 2. And it was probably understood by those people that it is not possible to give it is not a rational number, was kind of understood, and so they tried to give approximate value of square root of 2. Now, he gave what is called theorem of oblongs or rectangles. Theorem of oblongs. He gave in the form of a rectangle. This Pythagoras theorem, usually we write in terms of a right angle triangle. But Bodhayana states it in the form of a rectangle or oblong. So he says that you take the diagonal of the rectangle and its square is equal to the sum of squares of the other two sides. In a different way he says it. Okay. So the contents, what are the contents? So let us see those. So the methods of geometrical construction given by Bodhayana, they are very clear and precise. They are workable, means you can follow those geometrical constructions. I mean, they are not very complicated constructions that he gives, because in those times measurement was also difficult. So he gives such rules which can be worked out by somebody who is not a real mathematician. But these rules were used by architects also who are doing constructions of buildings. Okay. Long chord, chord is the same as Shulba or Rajju. These are the various names. They are used in building designs and such Shulba geometry. This is many times called Shulba geometry. That is chord geometry. So long chords, they are still used. And measuring tapes which we have nowadays, they are sophisticated form of chords. Now, Bodhayana being the most ancient geometer, most ancient means before Bodhayana also there would be, but we don't know who they were. So, the most ancient known geometer is Bodhayana. And the later mathematicians who were geometers and knowledgeable persons about Vedas also and also mathematics, they were Apastambha, Katyayana and Manu. And then later Shilva Sutras also have some versions of these sutras of Bodhayana. But some of the versions were better also, because mathematics always develops, so people have new and new ideas, and sometimes they also want to show that they have done their own research. So Katyayana, for example, has some results which are not in the work of Bodhayana, as we will see that thing also. Okay, now here you actually see what are the contents of the first chapter or first adhyaya of Bodhayana Shilva Sutra. Okay, so you see here units of measurement. Now the units are changed now. We have either inch, foot, or we can have centimeter, meter, and so on. So there were different units of measurement. Many times they used to use hasta, hand. So the measurements were related to the hand of the Yajamana. And Yajna also, the sizes of the Yajna Kunda, they related to the hand of the Yajamana. Drawing a square with the help of a chord alone. You want to draw a square, you have to construct a right angle. You have to construct a right angle. How will you construct a right angle? With the help of a chord only. So that was, this construction of a right angle is an important problem, which was discussed in different ways by people. And using Pythagoras theorem also, you can construct a right angle. And that was actually done, and it has its own application. Now drawing an oblong is rectangle. This is not much different from drawing a square, because in a square or an oblong, you have to construct right angles. So the sides are at right angles with each other. So four sides of a rectangle or the four sides of a square. So that every side is at right angles with the adjacent side. Now this is a question, important question. How to construct the side of a square whose area is twice the area of a given square. So if I have one square, I want a larger square, and the area of that square should be twice the area of the given square. How do you construct that? And this question is actually simple for a layman, but a layman will give you a wrong answer. So the layman will say, usually those who know are not much familiar with mathematics, they will say that if you want double area, then you take double the side. Instead of say 10 square foot, you make it 20 square foot. side, then the area will become double. That is an answer given by Lehman. And in those times also the same answer was there from the Lehman. And then Bodhayana therefore says that if you think this way, then that is not the correct answer. He actually warns you. And then he gives the method of constructing. Now everybody, we know what that method is. If you want to have twice the area, what you will do. But that is explained. Then after that, suppose you want thrice the area, what you will do. What you will do. That is explained by Bodhayana. This is actually going towards Pythagoras theorem. These two are the small steps. And then he gives you Pythagoras theorem. He doesn't directly state Pythagoras theorem. He gives step by step, gives you some exposure about this. In fact, we also should have this practice while teaching geometry in the schools. That directly, instead of directly going to Pythagoras theorem, we can think of this problem to motivate the students that if you want twice the area, what you will do. So twice the area, and then next question is n times the area. What you will do for n times the area? Do you have an answer to that? How will you have n times the area? We want a geometrical construction. Okay. Nowadays people will say n times area, everybody knows, multiply by root n, etc. But that is not a geometrical way. So geometrical method was given later on by Kapteyn. But in fact, using the method of Bodhayana and Pythagoras theorem, you can certainly construct the square or a rectangle whose area is n times the original area. You can do that. So Bodhayana theorem or Pythagoras theorem. Bodhayana theorem is the same as the Pythagoras theorem. Now there are different constructions which are there. You will be surprised that first constructions were discussed there. Method to combine two squares. What is the meaning of this? Combine two squares, that means you have one square, then another square is there. Now their areas are known to you, and you want to construct a third square which is bigger than both of them, such that the area of the bigger square is sum of the areas of these two squares. How will you construct that? That is the question. And that method he has given. Similarly, the other question is subtract. Subtract one square from a larger square. Subtract means what? You want to construct another square such that sum of these two is equal to that larger square. That is the area. Area is sum of the two areas. Convert a square into an oblong of the same area. So the same area is very important here, that you want to construct a specific oblong or rectangle of the same area. Convert a rectangle into a square of the same area by geometrical way. So you want a geometrical construction for this. Convert a square into a triangle of equal area. Convert a square into a rhombus or a double triangle. So rhombus, all the sides are the same. Double triangle, that is what you do is you have a line and you have a triangle which is isosceles on one side, and then take the reflection of that on the other side. So you get a double triangle. That is the same as rhombus. Now 13 and 14, they are more difficult. Turn a square into a circle of equal area. This is called circling a square, and the next thing is squaring a circle. That means we have a circle. That means its radius is known to you or diameter is known to you. Then you want a square of equal area. So this construction he gives. Why he gives such strange constructions? Because these constructions were actually required in the applications, and his application was a very interesting application about yajnas. So in the rituals, you require 3 yajna kundas, and they are, one of them is actually circular, another is square, and the third is semicircle. Semicircle. Now these 3 yajna kundas are there, altars There is an area around them, and then the sacrifices are done in the Yajna. But the requirement is that all these square geometrical figures, square, then circle and semicircle, they should have equal area. This is required for the religious purposes. So this is how mathematics was intertwined with religion. This is a mathematical requirement for a religious advantage. All the three Yajnakundas should be of the same area. But then those who are doing this Yajamana, who is doing the ritual, he doesn't know how to do that. And then a mathematical method was given by Bodhayana to actually do this. And that is to be done using a card, basically. No, there is a question whether you can actually do this or not by ruler and compass. So the Greeks were somewhat ahead in geometry in that period, and they thought of this problem: can you convert a square into a circle or circle into a square exactly? Here, the method of Bodhayana is such that you get some approximate equality of the areas. Because even if you have exact place in your method, your measuring instruments, they have a least count. So that least count, we cannot measure below that. So you cannot have your things very correct when you measure the things. And that's why whatever Bodhayana does is enough actually. And Bodhayana, his calculations are so good that he gives also an expression for square root of 2. And this expression is 1.41421 in the decimal terms which we nowadays use, using a decimal point. So in those times they did not use decimal point. Decimal point is a discovery, or it was used and made popular by some Arab mathematicians. It was not written as a dot in those times, but nowadays we are using a dot for the decimal point. So in those times the decimal point was not used, but whatever value of root 2 was given as a rational number. Rational number means you can actually construct any rational number by dividing the given card into equal number of parts. So there are constructions, geometrical constructions, which can construct a rational number. So this value of root 2 was given, and in a square, the diagonal is root 2 times the length of any side. And that root 2, how to construct that root 2? And numerically, its value is this much, and it was given by Bodhayana as a rational number. Calculations related to altars and their places surrounding that part also. So this geometry explained in chapter 1 is applied in all the later chapters. So you see that application is spread in 9 chapters. The original principles of geometry, they are contained in chapter 1, and all the applications. So falcon shaped or hawk, falcon, eagle, these are the prototypes. Chariot wheel, trough, tortoise, and also for cremation ground. That also is kind of a Yajna. So what is the shape of that was also discussed. So all that required geometry. So the point is that you might understand this thing, that this book or collection of sutras of Bodhayana is not a textbook on geometry. Please note, it is not a textbook of geometry. It is a textbook on altars, but in that textbook, he requires geometry. So all the geometrical principles which were required, they are collected in the first chapter, and later chapters use that. So that is what it is. So the applications and basic principles required for that. So now this is something behind this area should be double. It is required in practice in civil engineering. What are the sizes of the rooms? It depends upon what how you will utilize the room. From that the sizes of the rooms are decided. And so such questions, if right now you have a room which can accommodate 25 students, but if you want 50 students, what is the size of that room? So such questions you have to answer, and these questions were already answered by Bodhayana in his chapter 1. So basic question is how will you duplicate a square? If you have a square room which has size 10, you want a room which has double the area, how should we get the size of the new room? So doubling the side is not the answer. That's what Bodhayana mentions. Okay, now he gives a sutra for this thing. Samo chaturasrasya. Samo, you will understand, Samo means equal. Side. Chaturasra, Chatur means four. So four sides are there, they should be equal in all senses. Sama is the word used for this. Akshaya Rajjuhu. Rajjuhu means rope. So this Akshaya means slant rope. So this slant rope is slant rope you put there. Now you take this slant rope from the joining the opposite vertices of the Samachaturasra, that is the square. Now if you use that, then it makes double the area. Dvistavatim. Dvi means two, and Tavati means that much. Tavat, that much. Dvistavatim. So Tavati of that also, Tavati is also of that, Dvi, two times. Bhumi means area, Karoti means makes. Karoti makes. So a chord traced across a square, that is a diagonal, produces an area of double size, duplication of a square. So the proof of this is very simple that I have just drawn here. That what you do is you have this first square, take the diagonal. Now construct another square whose height is equal to that diagonal. Now if you join these diagonals of the new square, you will see that there are four triangles. And I have drawn here one more triangle outside the new square. Okay, you will see that black sides are there for that triangle. Now that triangle is equal to the original square has two parts, two equal triangles, and the new square has four equal parts, all of them are triangles, and those four triangles are there of equal area, and the area of them is equal to the area of the previous two triangles, each of the previous two triangles. Because the diagonal hypotenuse of all these right angle triangles is the same. That's why all of them have the equal area. So this is a proof that because four triangles for the new square and two triangles of equal area for the original square, that shows that the new square has four times triangle and two times triangle. So double the area of the original square. So that is how, this is a very simple proof that by taking the hypotenuse you get double area. How will you triple the area? Triplication of a square. Triplication of a square, Tristavatim moving. Instead of Dvistavatim, you want Tristavatim, three times. So here there is just a remark that construction by ruler and compass and origami. So this is the duplication of a square. There is a question nowadays duplication of a cube, can you construct the uh, side of a cube whose volume is two times the volume of the original cube? So for area you require root 2, construction of root 2, and construction of 2 is to 1 third is required, because if you want to duplicate a cube, that is its volume should be double than the double of the original. Then the side should be 2 is to 1 third times the size of the original cube. How will you achieve this 2 is to 1 third? So this modern field theory tells you that you cannot construct this by ruler and compass. This was a problem which was worrying the Greek mathematicians in those times. But if you use origami, then you can construct this thing. So you can uh, see some constructions in origami. You will learn that you can construct 2 raised to 1 third also using origami. So origami can tackle construction of numbers which are roots of cubic equations. So this is just a side remark. Now let us go to Samasya Trikarani. Samasya Trikarani. So 3 times. If you want 3 times the area, what he says, it is interesting how he develops the subject. Pramanam Tiryag. So Pramanam Tiryag. Whatever Pramanam means original, this is A, original A is this thing, A. You see here, the left one. Take the measure for breadth, and length is that for twice area. You see, for twice area, to make, you have solved the previous problem, right? Previous problem was doubling, duplication of the square. So for that, how did you get that side? That was the diagonal, that the hypotenuse or diagonal of the rectangle or hypotenuse of the right angle triangle. So it is the diagonal of the rectangle. Take that diagonal as one of the sides, that is the length. We can say length is a root 2. A root 2 we know now, it is written as a root 2, but it is the diagonal, diagonal of the earlier rectangle, earlier square, which was used for, which was a duplication of the square. So one side is A, other side is a root 2. Tasya Akshaya Rajju. Akshaya Rajju, now you remember, Akshaya Rajju means that diagonal of that rectangle. So you construct a rectangle, now we don't construct a square, but it's construct a rectangle. One side is A previous and other side is A root 2, which was the diagonal of the previous square. And then once this rectangle is constructed, you see that the diagonal is A root 3, and that is actually the side of a square whose area is thrice the original area. So this thrice area, you see here that if you want to go to Pythagoras theorem, if you want to use that, a square plus 2a square is equal to 3a square. This is what is happening there. So he is slowly taking you towards the Pythagoras theorem. The area of a square whose side is this diagonal will be thrice the original area. So length, one of the lengths is original A, another length is A root 2, which is the square, it is the side of the square whose area is twice that of the one. So I hope you understand this construction of Bodhayana. See how geometry was developed in those times, and they were using it for application. And now here only one remark, that it appears that this Dvikarani means 2 times your Karani means to make in some sense. So 2 times you make it. 3 times you make it. So that Karani, that was used for square roots by mathematicians later. So Dvikarani means root of 2, 3 Karani means root of 3, like that. So Karani, so for surds, the word Karani is used. The surds are studied. Please note that surds were also given by Indian mathematicians. We usually think that they have come from British people. That is not correct. surds were seen in the work of Brahmagupta. So he wrote Brahmasputa Siddhanta, and in his work you see the use of surds, how to add surds, how to multiply them, how to find the reciprocal of a surd. All these things were discussed by Brahmagupta, and you will be surprised that he also tells us how to find square root of a surd. That also is there. Square root of a surd. So now this is the main theorem which we want to discuss. Bodhayana theorem. You can either say Bodhayana theorem, or you can say Pythagoras theorem, or you can say Bodhayana Pythagoras theorem. Because if you say Bodhayana theorem, then people outside India may not understand. But nowadays they have also started understanding that Bodhayana theorem means Pythagoras theorem. But this says Dirgha Chaturashrasya Akshaya Rajyu. Akshaya Rajyu always means a slant rope. That is a diagonal. Dirgha Chaturasra. You take a Dirgha Chaturasra, that is a rectangle, and its diagonal you take. Now what does that diagonal do? Tat Ubhayam Karoti. Tat means that area, Ubhayam. Both the two sides, Parshvamani, Priyamani. Parshvamani means one side. Actually, vertical side is called Parshvamani, and Priyamani is perpendicular to that. That is perpendicular. That is Priyamani. So that is the horizontal side. Both these sides. So B and C here. B is Parshvamani, C is Priyamani. What area they make? B will make what area? So it will be B square. Of course, it is numerical thing, but geometrical area you see, and C makes an area. So a square is there whose side is C. What is the area made by that? So these two areas together are singly made by that A, which is the Akshaya Rajju, means what? Slant Rajju. Rajju means rope. So A square equal to B square plus C square in numbers. See, he is not talking in numbers. He is talking in terms of areas. So those who know Hindi, they can see that कर्ण की लंबाई की डोरी से क्षेत्रफल बनाती है, वो दोनों भुजाओं से स्वतंत्र बने कुलों क्षेत्रफल से मिलता है. So this is Pythagoras. He was around the time 570 to 495 BCE. He writes in terms of triangle, as we understand, but Bodhayana wrote in terms of a rectangle. There is a small difference in the way of expressing, because Bodhayana is saying in terms of areas, whereas Pythagoras is saying in terms of squares. Okay, now this is something very interesting, and we will stop after this, and then we can, if you have any questions, then we can discuss those. So we know that here, when you do this construction of a square whose area is twice, we know that the new side is a times root 2, and Bodhayana also knows that, and therefore he also finds a numerical expression for root 2. And what is this numerical expression? You have to approximate root 2 by a rational number. And what is that rational number? Which gives you a close approximation to root 2. So earlier you have seen this 1.41421. That was something there. In decimal, using decimal point, we write that. But his expression is like this. Root 2 is approximately equal to 1 plus 1 upon 3 plus 1 upon 3 into 4 minus 1 upon 3 into 4 into 34. So usually, how does Bodhayana get this? So, of course, Bodhayana has diagrams, and he has already constructed a length which is root 2 times the given length, because he uses a diagonal to do that. So he has that with him, and he understands that it is more than 1, of course. because that side is larger, diagonal is larger than side of the square. But then he also knows it is more than 1 plus 1 upon 3, 4/3. It is more than that. So maybe he might have tried and slightly add 1/4 of that part. See that there is a length 1, divide it into 3 equal parts. Then you know 1/3 of that. That you add, that much length you can have. Now this 1/3 you have, divide it into 4 equal parts. That gives you 1 upon 3 into 4. 1 upon, it is not 3.4, it is 3 into 4. 1 upon 12 it is actually. So 1 plus 1 upon 3 plus 1 upon 12. These numbers are called as unit fractions. 1 upon 3. Top is 1 and denominator. So you are dividing 1 into 3 equal parts. Whatever unit is there, you are dividing into that many equal parts. That 1/3 you again divided into 4 equal parts. That much you add. Now, if you add that, what happens is you are crossing root 2. You get a length which is slightly larger than root 2. So 1 means 1 unit, whatever it is, 1 foot, 1 meter, whatever it is. Some unit, 1 unit. Add 1/3 of that. Pramanam, he uses the word pramanam. Pramanam means some unit. It can be just hand, or it can be the height of a person. Purusha, height of a person. Whatever that unit is, you add 1/3 of that, then of that you add 4th part. That's what it says. Now it becomes slightly more than root 2. Then you subtract, take out something. So how much? It is slightly larger than root 2, so you don't have to take out much. Already you have added 1/12. Some part of that we should subtract. What is that part? It is 34th part of that 1/12. Okay? That much we should remove. And that gives you good approximation for root 2 is what Bodhayana says. Now the question is, how does he get this number 34? Is it by trial? That's the question. Probably 1/12 he can get by trial, because you have to use some simple numbers, and dividing by 4 is easy because we have a string, then divide into 2 parts. So just by fold it. One more fold is there, then you get 1/4 of that chord. So if you have a chord of length 1/3, then you can fold it 2 times to get 1/12 of that. That's an easy construction. So the construction should also be easy. Now you can stop here, but if you are still interested in getting a better approximation, then you have to go to 1 upon 3 into 4 into 34. Not 32, 33 or 35. These are 32, 30, 34 is good number actually, because by folding and folding, 2, 4, 8, 16, 32. But even if it is a simple number, it doesn't say 32, use 32 because it is simple. He gives a better thing, which is the best thing out of small number. 32, 33, 34, 35. 34 is the best, and how do you know that? It cannot be done by trial and error. You have to know some mathematics behind it. And what is that mathematics? That is what we should, you can also think about what that mathematics is. How he gets 34. Please think about it. So you can try to find out the answer to this question. Okay? Please think about this question. And now what he says, let us actually see the construction of Bodhayana in sutra form. It is 61st sutra. And Samasya Dvikarani. Now you have understood duplication of a square. Once you do that, for that you require some length which is root 2 times the original length. So one finds the side of a new square in the following way. So original side is 1, let us say 1 unit. Usually it will be 1 unit, 1 hasta of the yajman or performer is 1 hasta. Then pramanam, that much, Tritiyena vardhayet. Tritiya means one third. Tritiya, third part. Okay, 3 means 3. 3 is a similar thing. Tritiya, one third of that you increase by one third of that. So 1 plus 1 upon 3. It is easy to understand this thing. Pramanam means unit. Whatever unit is there, you increase by one third. Then what you should do? Just you should remember this verse. Tat chaturthena. Tat means that one. So that one third is there. That you increase by one fourth of that. Chaturtha. Chaturtha means fourth part. 1 upon 3 divided by 4. So it is 1 upon 3 into 4. Okay. Now you have crossed root 2. So what you will do? You should come back to subtract something. What you should subtract? Atma means sataha, self. Atma means self. So self is that number which you have obtained, 1 upon 3 into 4. Chatustrivisha, this is Sanskrit word. Chatustrivisha, Chatu means 4 and Trivisha is 30. Trivisha is 30. 34. Chatustrivisha is 34. So Chatustrivisha, un means subtract. Okay? Un is subtract. In Marathi or Hindi we say Ekona 20. Ek una 20. 20 subtract 1, 20 subtract 1, you get 19. So Ekona 20 or Ekon 20 or Ekonis, these are some words in different dialects. Untalis in Hindi, un means una. Un means less. Untalis in Hindi. Okay, untis. So less, slightly less than 40. Untalis, slightly less than 30. Untis. Okay, here we say ekuntis, like that. Un means less. So less, how much? 34th part of whatever last thing is, that you should subtract. So formula becomes root 2 is approximately equal to 1 plus 1 upon 3 plus 1 upon 3 into 4 minus 1 upon 3 into 4 into 34. And that approximation by whatever way 34 is obtained by our mathematician Bodhayana gives you a value of root 2 correct to 5 places of decimal, which is a very good achievement. It is outstanding achievement, but if you can think of a method, then we know that Bodhayana can still get a better approximation. If you want the value correct to 10 places of decimal, Bodhayana has a mechanism using which in the next step he can get the value correct to 10 places of decimal. But he doesn't do that. Why? For the obvious reason that there is no use of that. I mean, you are not going to Jupiter or Mars or Moon also. So you have to measure whatever you are, that number which you should be able to construct it. If it is correct to 10 places of decimal, it will be difficult to construct that number using card only. You have to do everything using a card. And although he knows the mathematics behind it, he does not go ahead and doesn't get the value correct to 10 places or 20 places of decimal, although he knows it, but you can do it by using the technique of Bodhayana.